Hi all, I welcome you all to the new video today. So very good afternoon to all. This is Michael Jones, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. So in today's lecture, we will study the different types of industrial robots based upon their mechanical configuration, movement characteristics. So robots are designed for various applications and their structure determines the workspace, flexibility, accuracy and suitability to perform any specific task. The major robot configurations include a Cartesian, cylinder, polar, articulated, and SCARA robots. So understanding these classifications helps engineers to select the most appropriate robot for industrial and automation applications. So let us begin with a Cartesian robot. A Cartesian robot moves along the three mutually perpendicular linear axes X, Y, and Z. Because of these coordinate system, it is also known as rectangular robot or a gantry robot. So the robot's movement is simple, highly accurate, and each axis moves independently in a straight line. The key features include linear motion along all the three mutually perpendicular axes X, Y, and Z directions, high precision and repeatability, simple control and programming, large rectangular workspace can be used. Then the applications in CNC machines, 3D printing, pick and place operations, automated assembly systems. So all these areas we can see a Cartesian robot. The major advantage of a Cartesian robot is their high positional accuracy, making them ideal for applications requiring precise movement. Next, we have the cylindrical robot. A cylindrical robot combines a rotational movement around the central axis, vertical linear movement along the vertical and horizontal directions. As a result, its workspace resembles like a cylinder. The key features are one rotational joint and multiple linear joints. Cylindrical working envelope. Better reach around the obstacles compared to a Cartesian robots. So applications like material handling, machine loading and unloading, spot welding, assembly operations can be used in a cylindrical robot. The cylindrical robot provides greater flexibility than a Cartesian robot while maintaining relatively simple construction. Now let us discuss about a polar robot, also known as a spherical robot. A polar robot consists of rotational joints with a telescopic arm. Its movement creates a spherical workspace, allowing the robot to reach a wide range of positions. Key features include a combination of rotary and linear motion, large spherical work envelope, high flexibility in reaching different locations. Some of the applications like die casting operations, arc welding, material transfer, industrial automation tasks. So these are the places where we can use a polar robot. The spherical workspace allows the robot to access locations and it may be difficult for a Cartesian and a cylindrical robots. Finally, moving to articulated robot. So we study articulated robot. This is the most widely used industrial robot today. An articulated robot resembles the human arm and consists of multiple rotary joints connected in series. So depending upon the application, articulated robots may have 4, 5, 6 or even more degrees of freedom. Some of the key features are like human arm-like structure, the main key feature, then multiple rotational joints, high flexibility and dexterity. So these are large and versatile workspace. Applications like welding, painting, assembling, and material handling, packaging. So all these areas we can see an articulated robot. Articulated robot are very common in educational purposes also. We can see articulated robot for a learning purpose. Then because of these flexibility and ability to perform complex motions, articulated robots are commonly found in automotive and manufacturing industries. So to conclude this, summarize, we explored four major robot configurations. So they are Cartesian robot, cylindrical robot, polar robot, and articulated robots. Each type offers unique advantages in terms of workspace, movement, and industrial applications. So in the next lecture, we will continue our discussion on robots classifications and study SCARA robots along with the comparative analysis of different other robotic configurations. So I hope this video would have given you a very good information about the different types of robots. So thank you all.